So since we have already finished the paper 1, now it's time to start the paper 2 discussion. So I warmly welcome you all to the paper discussion of properly. So we will be giving you solutions in a simple way which you have already studied in properly. Alright. So if you look at this question, first question, during sodium nitroprosate test for sulfide ion in an aqueous solution, one of the ligands coordinate to the metal ion is converted into. So this is very simple only. Sulfide ion will generally be S2 minus. It can be Na2S also. Na2S also it will be existing. So let's write instead of S2 minus, let's write that only. Na2S will be there. So sodium nitroprosate will be having Na2 Fe Cn5 times NO. So this is the sodium nitroprosate. So cyanide will not be changing, only NO will be changed. So NO will be changed into, this will be changed into Na4 Fe Cn5 times NOS. So this will be changed into NOS minus ligand. Alright. So the answer will be option A. So in this question, we need to discuss the hydrolysis of ICl, ClF3 and BrF5. So whenever this fluorine end is there, they will generally will be giving their corresponding halogen acids. Whenever you have two halogens in a particular compound, more electronegative atom will be forming corresponding halogen acid. That is the one thing which you need to remember here. So ICl is there when it is reacting with H2O. When it is reacting with H2O, what will happen is H2O is there. It will react to form, first of all, HCl because Cl is more electronegative, and the other one will be forming HOI, which will dissociate to give IO minus. Okay, this is also comparatively less stable, so this can also dissociate to form IO3 minus and I2. It will undergo disproportionation reaction in liquid solutions generally. That is what will happen. I minus and IO3 minus will again form. So that anyway will be like backward reaction forming. So we will be end up with the product only IO minus. Okay. So looking at the other option, we will be getting ClF3, which will undergo hydrolysis to form HF, of course, and the remaining part will combine with Cl and they will be forming HClO2. This is the interhalogen compounds, which is a particular portion P block elements in NCERT itself. It is there. Okay, so this is equivalent to our ClO2 minus ion. Now, if you look at the last one, BrF5, BrF5 is there. So when it will react with H2O, we will be ending up with HF as well as we will be getting HBRO3, or this will be translated as BRO3 minus. So the question, do we need to by heart this? No need. Okay, so here actually you can see simple some of the patterns you can see here. ICl, I plus and minus is there. They will again be changing into corresponding HOI, where it will be 2 minus oxygen and this will be 1 plus. So that means whatever the less electronegative atom, they are not changing anything. They are staying in the same state in the product also. Here if you see plus 3 it is there, that is also changed. Nothing is changing. It is remaining as plus 3 only in the product also. Here it is in plus 5. In the product also it is plus 5. Alright. So BrF5 is changing into HBRO3 or BrO3 minus. So you can check the options, corresponding options. Where the oxidation state of that is same, that is the correct option. So option A will be the correct answer. So that is the answer to second question. So now look at the third question, which is an organic reaction. So we need to look at what are the products which will be having more highest unsaturated carbon. I mean more double bonds are in which compound? That is a question. Okay. So if you look at the first one, that is basically HVZ, Helmholtz-Zelensky reaction. HVZ reaction, you know what are the products. So you will be getting the products, or benzene ring will be there. Alpha carbon to the carboxylic group will be halogenated. I mean here bromine is there, so Br will be there. So this reaction, second one, this is a normal aldol condensation. You will be getting alpha, beta, unsaturated. They have also heated. 293 Kelvin means little bit heat is also there. That means we'll be getting unsaturated alpha, beta, unsaturated compound, not an aldol. So you'll be end up with something like this. CHO will be there, so here it is fine. So now if you look at the third option, what is happening here? So initially you will be getting a product which will be looking something like this, which is again attached to this here double bond, where here one negative charge will be there, that is attacking here, this will go and Br will leave. So we will get a product like this. That is the first step. So when you are undergoing Hg2 plus H3O plus, which is oxymercuration, this will be normal attack of OH will be happening at the more substituted position here as well as here. So you will be getting a product which is looking something like this, where we'll be getting OH double bond followed by one OH here and one bond here. This will undergo tautomerization and you will be end up with a product of C double bond O, OH and a carbon group. So this is the answer. So if you look at the first one, ozonolysis. So if you undergo ozonolysis, this bond will break and you will get this product which will be looking like this. Okay, C double bond O, and on the below portion we will be getting C double bond O H. Okay, one ketone as well as one aldehyde we will be getting. So we have two equivalents of CH3 MgBr. I mean CH3 will be CH3 minus alkyl group will attack on the both carbonyl. Two equivalents means two of them are there, they both will attack here. So we will end up with, finally after undergoing hydrolysis, after which here O minus will be there, that will abstract 1 protons each. Then what we will get? We will get OH as well as here something like that. Here also one OH will be there as well as one CH3 group will be there and one H is also there. So these are the products. Now question is, highest unsaturated carbon means more number of either sp2 or sp carbons. So if you look at the, all of them have benzene, so we just need to look at the other carbons. So here if you look, 1 2 3 carbons are there, 3 unsaturated carbons in Q. If you look at here total of, other than benzene, here one more is there. And if you look at this one total we have only one, here 0 is there other than that. So our answer will be Q. Okay, because Q will be having, not Q exactly, actually sorry, in this last option, one thing which I have mixed here, other than Q, here actually last option along H plus means H plus we are heating. So when we are heating here, we will be ending up with something like this. Some double bond can also form here. So this we will be getting. So here also as you can see 1 2 3 4 are there. So instead of this one Q, our S will end up as the winner in this championship of unsaturated carbon. So our answer will be option D and not option B. There might be a chance we will directly jump into here. So that is not the answer. Answer will be option D. Alright, so now let's look at the question number 4, where we need to find where it is forming dicarboxylic acid. So let's look at this fast. So first one, Cl is there, OH minus is there, NaCN, where we will be having Cn minus nucleophile. So nucleophile will attack at that position where there is a good leaving group. So if you look here, only Cl is a good leaving group compared to OH. So we will be getting HO as well as Cn. When Cn is reacted with OH minus, what will happen? We will be getting an amide. We will be end up with a amide, CONH2. After so much step, okay, this is not immediately first step reaction, H2O protonation and all this. Finally, we will be getting an amide. When amide is undergoing hydrolysis, we will end up with corresponding carboxylic acid. So we will be getting carboxylic acids, but it's a monocarboxylic acid. So A is incorrect. Look at the second option, that is basically glucose reacting with bromine water. Bromine water is a weak oxidizing agent, not a strong oxidizing agent. That means it will only oxidize CHO group. So you will be getting COOH here. Remaining part will remain more or less same only. That means primary alcohol will not get affected. But instead of this, if you are having like concentrated HNO3, that will completely oxidize both the primary alcohol as well as the aldehyde. So here they have given bromine water, so we don't need to worry about that. So here also this is also an incorrect option. Look at the third option, KOH, ETOH, ethanol, and KOH, alcoholic OH minus. Whenever you have a alcoholic aqueous, we should never have that confusion. I'm pretty sure that none of you will be having that confusion either. Alcoholic KOH means that will definitely be acting as a base. Base means it will take one hydrogen from here and our bromine will be elimination. So we will be getting a product like this which will react with MnO4 minus, I mean KMnO4, which is a strong oxidizing agent in presence of acid followed by heating. We will be getting the maximum product which will be possible from here, that is carboxylic acid. Yes, so our answer will be option C, where we will be getting dicarboxylic acid. We don't need to look at the last one. H2CrO4 is a constant, sorry, a highly stronger oxidizing agent. So that will only be affecting primary alcohols, not the ketones. So we will be getting a product which is looking like this. This is also a monocarboxylic acid, so that is an incorrect option. So correct answer is option C.
This question, correct statements you have to identify about intermolecular forces. And this topic already I have taken in the class in S block element when we study weak force, strong forces there. The first option given is the potential energy between 2 point charges approaches zero more rapidly than the potential energy between a point dipole and a point charge as the distance between them approach infinity. Now first you need to identify what this point charge. The examiner trying to say you that it is nothing but the ions. Okay. So the potential energy between ions, ion energy, we know is directly proportional to 1 by r. Next is between point dipole and point charge. So it is nothing but ion dipole interaction. So potential energy of ion dipole is proportional to 1 by r square or inverse proportional to r square. Now you tell me like what it is trying to say, the potential energy between 2 point charges approach zero more rapidly than potential energy between a point dipole and a point charge. The distance between them approach infinity. We are increasing the distance, r value we are increasing. So when we are increasing the distance, definitely potential energy will decrease. This r will increase, these potential energies will decrease. Its approach is zero more rapidly, it is saying. Now we'll see if we increase the distance, this decrease in the potential energies ion dipole will be more than the ion-ion interaction because it is directly inversely proportional to r to the power square. So this statement is incorrect. It will approach zero more rapidly in case of ion dipole, not in case of ion-ion. Now next statement is the average potential energy of two rotating polar molecules. Two rotating polar molecules that are separated by a distance r has a 1 by r3 dependence. Now these are the polar compound. We can say having the dipole over there, positive and negative charge, right? But they are rotating. And if they are rotating, their energy dependence will be 1 by r to the power 6, not the 1 by r to the power 3. It is in case of stationary. So this statement is also incorrect. Now next is the dipole induced dipole average interaction energy is independent of temperature. Now dipole induced dipole, it is nothing but over here the interaction between one dipole who is creating dipole in the another compound, right? What it is saying that it's independent of temperature. Yeah, for sure, because whenever we do the any thermal motion or any thermal process over there, it will not have any impact over the average interaction energy. This is clear. So it will not have any impact over the temperature, or the thermal motion will not have any impact over the average interaction energy. So this statement is correct. Now next statement is Non-polar molecules attract one another even though neither has a permanent dipole moment. Non-polar molecule, and in case of non-polar molecule we have seen the instantaneous dipole induced dipole interaction. Instantaneous dipole induced dipole interaction, which we generally called as London forces as well. London forces. So what happened? They, even though they don't have the permanent dipole, but still they attract because instantaneously they result in the creation of the dipole with the between two different molecules over there. The one will attract another, it will create a dipole. It's not a permanent, it's very weakly attracted, not strongly. So this one is also correct, like because in spite of, despite they don't have the permanent dipole, still they attract each other. Reason is instantaneously they will create a somewhat little bit amount of dipole over there that will attract each other. So this statement is correct. This question is the compounds with pH bond is R. As already we have done in our classroom here, that first one is S3PO4, S3PO3, H4P2O7, S3PO2. So I have already taken this topic of oxyacid of phosphorus. So let's see how we can use over here. Oxyacid of phosphorus, I have given some method to find out the structure. Here I will write down directly S3PO4 structure is this one, and we are keep reducing one oxygen, minus one oxygen, minus one oxygen. It means its structure will become minus O over here. It will give you O, H here, OH, OH. This is your S3PO4 phosphoric acid. This is your S3PO3 phosphorus acid. Then remove one more oxygen. It will give you P double bond O, OH, H and H. This is your S3PO2 hypophosphorus acid. So if you look at in this option, this is having pH bond and this one is also having pH bond. So option number 3, option number B and D are correct. Now let's look at the structure of S4P2O7. It's a pyrophosphoric acid and the basic skeleton structure will draw. It is having oxy linkage over there, P double bond. Now 4 oxygen and 5 hydrogens are remaining. Uniformly will distribute them, OH over here, one OH over here, another here and last over here. Now if we look at this compound, we don't have any phosphorus hydrogen bond. So this will not be the answer. So correct options are your B and D. Question number 7. For the reaction sequence given below, the correct statement is R. Both X and Y are oxygen containing compound. First we will see the passage, try to solve the what will be the product X and Y and Z, and then we'll read the options. First, what the question is saying, that in this compound we have added the KMnO4H plus. So what's the purpose of KMnO4H plus? All of you must be knowing that it will do the oxidation of the compound having alpha hydrogen, right? At least one alpha hydrogen must be there. And the next step is, so it will form the carboxylic acid here. And next step they have given you addition of the ammonia, and we are heating, that is resulting in the release of water. So let's do this stepwise. First is what? KMnO4. KMnO4 in acidic medium, we are heating this compound. This will break from here and will form the carboxylic acid. Its name is phthalic acid. phthalic acid. Now next is we are adding ammonia, heating it, and examiner itself has said you that you have to remove the two water molecule. Now let's see how the reaction will happen over here. Just remove HNH2, HNH2. This water molecule will be removed from here. C double bond O, NH2, C double bond O, NH2. So we form the amide over here. First a carboxylate like salt will be, ammonium salt will be forming, and then we'll remove the water. That stepwise we don't have to go for the mechanism. Just I am telling you the simple way how you can make the amide from the carboxylic acid and the ammonia. Now next, this compound is our compound X. Next is in this X we are adding strong heating. So first is strong heating, then doing the addition of ethanolic KOH, and then reaction with the RBR. Let's do this. Strong heating. When we do the strong heating, you must be getting some idea what idea that we have already done it in the class. It will result in the formation of your thalamide, right? So isn't it looking like we are moving toward the Gabriel thalamide synthesis of the amines, right? So it's a thalamide. This thalamide, next step is addition of, treated it with ethanolic KOH. Ethanolic KOH, it will remove the acidic hydrogen. This hydrogen being the acidic will be removed by the OH minus ion. It will form N minus K plus over there. Now next step is addition of RBR. Third step given is RBR addition. Now what will happen over there? Since RBR we have, this N minus will be attacking over the R group, Br minus will leave from here. We will get this compound. C double bond O, this one. Now next step, this is your Y. Now next is, in Y we are adding sodium hydroxide. It will result in the formation of aromatic compound and the Z. When you add the NaOH over there or the KOH, when you treat it with this base, it will result in the formation of Na plus CO minus Na plus. So sodium salt of phthalic acid over there plus RNH2 primary amine. This is your Z, primary amine. Now options, let's see on the options given in the question. Both X and Y are oxygen containing compound. Let's see where is the X. This is the X, right? It is having oxygen, 2 oxygen. Y, it is the Y, it is also having oxygen. So this option is correct. Y on heating with chloroform KOH form isocyanide. See where is the Y? This is the Y. And for the isocyanide test, carbylamine test, we required the primary amine. Means Z will be reacting with chloroform KOH and will form your isocyanide, not the Y. So this statement is given is incorrect. Next is Z react with Hinsberg reagent. And last option, Z is an aromatic primary amine. We can't say whether it is aromatic over here or not. First of all, the thing which we can interpret from here is, this examiner has mentioned R instead of ARBR, right? So we can predict somewhat that it can be aliphatic there. We cannot say 100% it is an aromatic there. Aromatic primary. So this one is also incorrect. Z reacts with Hinsberg's reagent. Let's see the reaction of the Z with Hinsberg. If you remember that Hinsberg test is given by your primary amine, right? So this is also correct. Let's see the Hinsberg first over here, how it will form. We have the Z, RNS2. In this RNS2, we add the pH SO2Cl, which is benzene sulfonyl chloride. pH SO2 NHR. N alkyl, this HCl will be removed from here. This H and this Cl. It will form your N alkyl benzene sulfonamide. Now further we react it with the sodium hydroxide, that as usual Hinsberg test over there. It will form the soluble salt because it is having acidic hydrogen. So what will happen here? pH SO2 and R minus Na plus. So this Z is going to give you the Hinsberg reagent test with Hinsberg reagent. So it's done. Now this question, for the reaction sequence given below, the correct statement is a multiple choice question it is. Now first, it is a cyclic ester in which we are adding lithium aluminum hydride. So what is the use of LiLH4? It will do the reduction and will convert it into alcohol. Next is CrO3 H2SO4 we have added, which will convert it into acid, and that acid we are doing a decarboxylation by addition of sodium hydroxide, calcium oxide over there. Next is from P to S, H2SO4 is added there and it is heated, and here we are getting S. So let's see what we will get. Definitely it will do dehydration. So let's see the products. Now first is this one. pH and then adding LiLH. To break this bond, you will get the alcohol CH2OH, and this is also CH2OH, the pH. This is your compound P. Yes. Now next is addition of CrO3 H2SO4. It will convert this alcohol and further oxidize into acid COH. This is your. Now further we are adding sodium hydroxide, calcium oxide and heating it. Sodium hydroxide, calcium oxide, heated. This is nothing but your decarboxylation. 2 CO2 molecule will be removed from here, and you will get this compound R over here. pH. Now this is your R. Now next is with the P, they are adding. In P itself, they are adding H2SO4 and heating it at 443 Kelvin. H2SO4 addition, we know that it will be doing dehydration via carbocation formation there. Yes. So dehydration when we will do over here, it will result in the formation of carbocation here. and this carbocation will shift to the secondary carbocation which is stable, and it will undergo dehydration, will form a pi bond over here. Similarly, the carbocation which is generated over here will also undergo dehydration, will form a pi bond over here. So we'll write down the structure directly here. It's a simple step. Now it will result in the formation of this type of compound. This. This will be your S. Now all the compounds we have identified P, Q, R and S. Now let's see what are the options given there. First option is P is optically active. Is P optically active? No, because see here, this group is same and this one group is also same. It means, let's say this one carbon center is there, whether it is chiral or not, let's check it. Over this carbon we have two same group. It means this is going to be your achiral. I can pass a plane of symmetry across this plane. So this compound is optically inactive. So option 1 is incorrect. S gives Bayer's test. Bayer's test is for unsaturation. The compound having double bond, triple bond, they will give you the Bayer's test. So definitely S will give you the Bayer's test. Q gives effervescence with aqueous sodium bicarbonate. It means Q must be your acid over there. So let's see where is the Q. This is the Q. And if you see in the Q, we have the carboxylic acid, which is a stronger acid. So definitely when we remove this H plus ion, the conjugate base will be stable. And then H plus ion will be reacting with your sodium bicarbonate, will form that will result in the formation of the salt of carboxylate over there and H2CO3. So it will give you the effervescence, and that H2CO3 will further break down into H2O plus CO2. So option C is also correct, that effervescence you are getting from the CO2 formation. R is an alkyne. See, look at there, R. R can never be the alkyne because we are doing the decarboxylation there. So this option is incorrect. So only option number B and C are the correct over here. Now the question given is, the density is gram per centimeter cube of the metal which forms a cubic close packed lattice with an axial distance, edge length is given to us, which is equal to 400 picometer. Atomic mass of metal is also given in the question itself, and Avogadro constant value is simplified, 6 into 10 to the power 23. Now see, this question is directly based on the formula that many of you must be remembering, that density of a unit cell is equal to Z into M divided by NaAQ. Z is the number of atoms and A is the edge length and M is the mass, atomic mass, or either it's a molecule, so molecular mass will take over there. So atomic mass of the metal is given to you. Now let's see here. It's asking gram per centimeter cube, and for CCP we know that number of atoms are 4 over there. Edge length is 400 picometer. This we can convert into centimeter. It will become 4 into 10 to the power minus 8 centimeter. Atomic mass is given to you, 105.6 mu. Now we can just substitute directly the value. So density will become over here 4 multiplied by atomic mass 105.6 divided by gram per mole divided by Na Avogadro's constant, which is 6 into 10 to the power 23 per mole, multiplied by edge length. Edge length is 4 into 10 to the power minus 8 centimeter whole cube. When you calculate this, it will come out to be 11 gram per centimeter cube. This is the density. So direct formula based question, it is very easy. Now see this question. The solubility of barium iodide in an aqueous solution is asked from us. How much is the solubility? And how we are preparing this? By mixing the barium nitrate with sodium iodide. Solubility product of barium iodide is given to us already. It means it's a sparingly soluble salt which is having some Ksp 1.58 into 10 to minus 9. Now let's see the reaction how it will be happening over here. Barium nitrate BaNO3 whole twice when it is mixed with sodium iodide NaIO3. It results in the formation of barium iodide plus sodium nitrate. Now it will take, just to balance it, we will take it 2 and 2 over here. Now what is the information given to us is 200 ml of barium nitrate and having the concentration 0.01 molar. Sodium iodide is 100 ml having concentration 0.10 molar. Number of moles can we calculate? Yes, directly. This is number of moles will be molarity into volume. So number of millimoles of barium nitrate will become 2 millimole. Number of millimoles of sodium iodide will become 10 millimole. Now, which one is acting as a limiting reagent? Definitely your barium nitrate here is acting as a limiting reagent. It is stoichiometric coefficient is very less. Now, so barium nitrate is the species which will get completely consumed in this reaction. So write it down. After time t, 0 moles of barium nitrate will be remaining, 2 moles will be consumed, and how many moles of sodium iodide will remain over there? 10 minus 4 equal to 6 millimoles. Now, how many moles of barium iodide will form? 1 mole is giving you 1 mole of barium iodide. Then 2 mole of barium nitrate will give you 2 millimoles of barium iodide. So write it down, 2 millimoles. Now see here, sodium nitrate will become 4 millimole. Now this information we have. Now the another information they have given to you is the Ksp of barium iodide. The Ksp of barium iodide is 1.58 into 10 to the power minus 9. Now see here, how can I write down its Ksp equation over here? Barium iodide will be giving you barium 2 plus 2IO3 minus. Let's suppose solubility is S of barium iodide. So when it will decompose, it will give you barium 2 plus S and 2S of iodide, right? Let's suppose initial is S is completely decomposed and will give you S amount of barium 2 plus and 2S of iodide. Now, you might be wondering, if you look at this reaction, is barium iodide is the only source of iodide and barium 2 plus here? No. What are the species remaining in the reaction mixture? Sodium iodide, barium iodide, sodium nitrate, right? It means who else is the, firstly we will see the source of iodide. So sodium iodide, if you see, is a source of IO3 minus also. It means barium iodide is not the compound who is solely responsible for the iodide ion. There is another source of iodide also present in the mixture, which is NaIO3. So can I say sodium iodide, here I am solving it, IO3 minus concentration, here it will become 6 millimole divided by 300 ml total volume. This we are getting from the sodium iodide. So it will become 2 into 10 to the power minus 2 molar. Now barium iodide is a solid, first of all. Here you can write down it is solid, and the previous reaction we are doing in the aqueous. This is the aqueous, this one is also aqueous. When they combine together, they will form the solid barium iodide and the aqueous sodium nitrate. Now see here, next step is, so can I say that I am getting 2s amount from the barium iodate of iodate ion and 2 into 10 to the minus 2 molar from the sodium iodate. So I'll add it over here plus 0.02. This is the overall concentration of iodate present in the mixture. Now if you look at here, further solve it. Ksp we can write down. Ksp is nothing but the product of ions of that compound. IO3 minus to the power 2. Now Ksp value is given to you 1.58 into 10 to the power minus 9. Barium 2 plus concentration, we don't know what is the solubility there, so we'll use it as a S. But we know iodate. Iodate is 2s plus 0.02. Now this 2s plus 0.02 we can approximate equal to, see this 2s value is going to be very less than the 0.02. When we are adding with the 0.02, it means it will be the lesser quantity. So we'll neglect it and approximate it to 0.02 over here. 0.02 to the power 2. When you take square of this now, so it will come out very less, 2s. Now so from here you will calculate the S equal to 4 into 10 to the power minus 4, 1.58, this is the S, into 10 to the power minus 9. So value of the S will come out to be equal 3.95 into 10 to the power minus 6 molar. This is the S. And S is the solid, nothing but the solubility of your barium iodate. So the value of S is 3.95 into 10 to the minus 6, and examiner has asked you the value of this thing. 10 to the power minus 6 is already given, so we'll have to just report it in the answer as 3.95.
Question number 11. Absorption of phenol from its aqueous solution onto a fly ash obey Freundlich isotherm curve. Actually, this is an equation for which we are absorbing some absorbate in an absorbent at the given temperature. So we can see from 10 milligram per gram to 16 milligram per gram aqueous solution. Phenol has an aqueous solution. The concentration of absorbed phenol are measured to be 4 milligram per gram to 10 milligram per gram respectively. At this temperature, the concentration in milligram per gram of absorbed phenol from 20 milligram, we have to find milligram per gram. This is we have to find will be. So first of all, we have to write the value. So there are two conditions. At first of all, the initial concentration, that is 10 milligram per gram. At that point, the value of phenol absorbed, so extent by which phenol is absorbed, means x upon m value is 4 milligram per gram. At another concentration C2, that is 16 milligram per gram, at that point the extent by which phenol is absorbing in the solution is 10 milligram per gram. These are the given values. Now we can write the isotherm curve equation, that is x upon m is equal to k multiplied by c to power 1 upon n. X upon m is the extent by which absorbate is going to absorb in the absorbent. So this is the extent by which we are absorbing the substance. K and 1 upon n are constant. K multiplied by C multiplied by 1 upon n, and C is the concentration here, because this is an aqueous solution. Otherwise it will be a pressure of a gas. Now we can multiply by log from both the side. So log x upon n is equal to log k plus 1 upon n will get in multiply and log c. Now we just have to put these values in this particular equation. So now x upon m is log 4 is equal to log k, we have to find 1 upon n, and log c. Now log c for initial c1, that is log 10. After solving this, log 4 actually we can write log 2 to power 2. and log 2 is 0.3010. So approximate it will come out to be 0.6. Then log k plus 1 upon n, and log 10 will be 1. So this is the first equation we are getting. Again we can solve same for the second given values. So again, after applying log x upon m, so log x upon m, that is given 10, is equal to log k plus 1 upon n, and then log c, that is 16. Again, 1 upon n multiplied by log 16. Now to solve this equation, again we all know log 10 will become 1, equal to log k plus 1 upon n, and this log 16 we can write log 2 to power 4. This is how we can write, and we all know log 2 value is equal to 0.3010. So approximate we are taking it 0.3. So 1 equal to log k plus 1 upon n, and now this 4 will get in multiply. So 4 multiplied by 0.3, the final value we will get around 1.2. So this is, we can call equation second. So this is our second equation. And this was our first equation. Now we have two equation and two variable. So we can solve for one, like we can go for the 1 upon n value. And how we are going to solve? By subtracting equation second by first. So equation second minus equation first, we will get the value. So again, this is equation second. So LHS will be subtracted by LHS and RHS will be subtracted by RHS. So this is LHS, left hand side, 1 minus 0.6 is equal to log k minus log k. Now 1 upon n plus 1 upon n multiplied by 1.2 minus 1 upon n. Now these two values will cancel out. Minus 0.6, it will become 0.4 is equal to, and after we can take common from here. So 1.2 minus 1 multiplied by 1 upon n. So 0.4 is equal to 0.2 multiplied by 1 upon n. So this is the final 1 upon n value we are getting. After solving this, n will become 0.2 divided by 0.4, that is 2 by 4 and 1 by 2. So finally we can say the n is 0.5. So we got the value of n. So first variable is n equal to 0.5. After solving, we have to go for another part of this equation, because we have to find the value of phenol absorbed at 20 milligram per gram. So we have to find the value at this particular point. So n value we are getting finally 0.5. After this, we can again put these value to find the value of k. Now we can either put this value on equation first and or equation second. From both the equation we can get the value of x upon n. So let's take, we are putting this value in either of the equation. If I am putting this value on either on the equation, we can easily get the log k value. So log k will come out to be minus 1.4. Okay, because we have two variable and two equation. Either you can put this 0.5 either in this equation first or either in second. From both the equation we can get the value of log k, that is 1.4. Now we got the value of both the constant. Now we can apply this value to find the new value, because we have to find the extent by which phenol is absorbed at 20 milligram per gram of its concentration. So again we have to write the equation. So equation is actually again x log x upon m is equal to log k plus 1 upon n log c. This is the equation we have. So 1 upon n log c. In this equation we know the value of log k. Now we have given the value of concentration 1 upon n. We know the only value we have to find the extent by which this phenol is absorbing. So log x upon m will be log k log k value we know 1.4 minus 1.4. We can directly put the value minus 1.4 plus 1 upon n. So we now know the value of 1 upon n is 0.5, 1 upon 0.5 multiplied by log C, and new concentration we can see here in the question, that is 20 milligram per gram. So we can directly write log 20. Now after solving this equation we can directly go for the value of log x upon m. So how we are going to solve? Minus 1.4, again this is the value, yes, there is a 20, so log 20 we have to solve. So after solving this equation and after multiplying by 1 upon 0.5, we will finally get a value of 2.6, and after solving final value will be 1.2. so this is the value of log x upon m, that is 1.2, which we are getting. Now x upon will be, yes, now this is the value of log x upon m. We have to find the value of x upon m. So x upon will be anti-log of 1.2. So anti-log of 1.2 will come out to be, that is actually 10 to power 1.2. This is how we have to write anti-log. So x upon m will be 16 after solving this anti-log, 10 to power 1.2. Because log values are given. Now we know the value of x upon m. After finding the value of x upon m, actually equation is x upon m is equal to k multiplied by c to power 1 by n. This is the value of x upon m. Now we can write this equation for three values we are getting. Three equations we can create. For the first value, when the concentration, initial concentration we have taken, then x upon value, this extent is 4 is equal to k multiplied by concentration will be 10 to power 1 by n. This is the first equation we have, and we can check here, this is the first equation. When concentration is 10 and x upon m value will be 4, the extent by which absorbate is getting absorbed. For second equation, 10 is equal to k 16 to power 1 by n. This is the equation second. And now for the final equation, we know the final value we are getting, that is x, that we have to find, is equal to k multiplied by 10 to power 1 upon n, and the only value we have to find is this x. Okay. Now we already solved for the n value, and actually coming out to be 0.5, that we already solved. So 1 upon n can be written as 2. We have already find that n is 0.5. n is 0.5 means 1 upon n can be come out to be 2, like this. Now we can directly put these value and we can find our answer in this particular equation. K value we already know, so either we can divide the equation or either we can solve, because we already know the value of k. These are constant and 1 upon n is constant. So x will be the value of k. So we all can see that is the value of log k. So we have to find the value of k, and how we are going to find the value of k is by equating these two equations. We can solve directly equations second and third. So this is equation second and equation third. After solving this, we can directly get the value. How we are getting the value? We can directly divide, because k will k. So we can dividing equation second by third. So 10 equal to k multiplied by 16 power 1 by n divided by x, that we have to find, equal to k 20 to power 1 by n. Now k to k will get cancelled out. So 10 upon x is equal to 16 upon 20 whole power 1 by n. Now we only have to solve this particular equation. So 10 upon x is equal to 16 upon 20, and we know that 1 upon n is actually 2. So we have to square the values and we will get our answer. So after solving this, x will become 20 divided by 16 square multiplied by 10. So x will be, after solving this, x will come out to be around 15.6. So this is our final answer.
Consider a reaction. So I have a reaction A plus R gives product. The rate of this reaction is measured to be, so the rate of this reaction is measured to be K into A and R. So this is going to be the second order reaction because this rate is dependent on both the reactant. At the start of the reaction, the concentration of R is R naught. So A plus R gives product at t is equal to 0, which is nothing but initial time. I am having R as R naught and A as A naught. And they have given the concentration of R, which is nothing but R naught, is 10 times the concentration of A naught. So I can write this as again 10 times the A naught. Okay. At t is equal to t, let's say the reaction can be considered to be pseudo first order reaction. Okay, initially they have used this equation, they have considered this as a second order, but now they are considering it as a pseudo first order with the assumption that K into R concentration would be equal to K dash. Let's see, it's a constant. Due to this assumption, the relative error. Okay, there we made an error because initially we considered this as a second order, but now it becomes a first order. There is an error in calculation. When this reaction is 40% complete. So 40% complete. What does it mean? 40% complete. A naught will lose 0.4 of A naught, right? That is a 40% of A naught. And this 10 A naught will also lose 0.4 A naught, 40%. And now at time is equal to t, what I have left is 0.6 A naught, and here I have 9.6 A naught. So this was considered to be second order. So let's consider the same equation as pseudo first order. So if I consider this equation as pseudo first order, A plus R gives product at time is equal to 0. I'll have A naught and I'll have 10 times the A naught of R and 0. But at time is equal to 0 when 40% is completed, so I will have same thing 0.6 A naught here, which is left now. But here the concentration of R is not going to change since it is present in excess. So the change is almost negligible. I'm not going to change this value. Now, what about the rate of this reaction? So rate is equal to, we know that it is dependent on only A. Now this K dash, that is mu rate constant, it is going to be K into R A, that is given in the question over here. Now I can write the rate of this equation K into, what is the R concentration? 10 A naught into 0.6 A naught, right? Now what about the error that we have made? So initially we considered a second order reaction, but now it become a pseudo first order reaction. So let's see. The rate that we have considered initially at a second order reaction, and the rate, the change in rate, now it become something, right? Some changes that we have made, some error that we have calculated. into 100 will give you the relative error, right? So the change in rate is going to be, okay, initial minus final. Like I can take this one first. So k into 10 a naught minus 0.6, sorry, 0.6 a naught minus, and the rate of this equation, oh we didn't write the rate for this equation, rate is equal to 0.6 a naught and 9.6 a naught minus 0.6 a naught into 9.6 a naught divided by the rate of 1. So the rate of 1 is going to be, like I forgot to write the k, rate of 1 is going to be same thing over here now, 0.6 a naught into 9.6 a naught. I can see the a naught square is common over here and down, so I can cancel all of them, right? And also the k that is common over here. Now I have only the numbers, that is nothing but 10 into 0.6 minus 0.6 into 9.6, I forgot to write 1 into 100, divided by 0.6 into 9.6 into 100. If you do this calculation, you will get 4.166, or you can write this as 4.167 or 17. So the answer will lies between 4.16 to 4.17. At 300 Kelvin, an ideal dilute solution of a macromolecule exact osmotic pressure that is expressed in terms of height. So how do I imagine this? I have a solution. Let's say I have a solution in this bottle. So this solution is height is going to be 2 centimeter. So how much force it is exacting on this surface is going to give you the osmotic pressure of that liquid. So how do I calculate this? This weight is due to the gravity, so I have to include gravity. So what do I have? This is rho hg, right? So pressure is going to be equal to density into height of the liquid and the gravitational force acting on that liquid, acceleration due to gravity. That is given as 10 meter per second. So what is their density? That is going to be 1 gram per cm cube. So I can write this as 1 gram per cm power minus 3 into height is going to be 2 centimeter and gravity is going to be 10 meter per second square. So I have to convert into their respective SI units. So I have meter here. So I have to convert all this centimeter to meter first and gram to kilogram. So how do I convert gram to kilogram? I know 1000 gram is equal to 1 kg or 1 gram is equal to 10 power minus 3 kg. So I can write this 1 gram as 10 power minus 3 kg divided by cm cube. I know 100 cm is equal to 1 meter or 1 cm is equal to 10 power minus 2 meter, right? So instead of the cm, I'm going to write minus 2 meter whole cube into 2 into 10 power minus 2 meter into 10 meter per second square. So 10 power minus 3 divided by 10 power minus 6 meter into 2 into 10 power minus 2 meter into 10. So what do I have here? So if this goes up, I will get 10 power 3 into 2 into 10 power minus 2 into 10. So this is going to be a Pascal, I can write, because SI unit of pressure is Pascal. So it is going to be 2 into 10 power 100 anyway. So 200 Pascals. This is going to be the pi. Pi is nothing but osmotic pressure. Now I know that osmotic pressure is going to be equal to concentration of that solution into gas constant into T. This, how do I get this? From the ideal gas equation. This N by V, moles per liter, I can take this as concentration. So CRT. Okay, P is going to be equal to CRT, not P. You can use pi here because of osmotic pressure. So what is the concentration of this solution? Okay, 2 gram per liter. They have given this concentration in gram per liter. Sorry, dm cube. 1 dm power minus 3 or 1 dm cube is equal to 1 liter. So pi is going to be like I can write this as 2 gram per liter. I can convert this into exact mole per liter so that I can use here molarity. So I know that given mass by molar mass is going to give you the moles. So given mass by molar mass, I can take it as m, and liter, that I'm just leaving it. Anyway, 1 liter. So I can write this as 2 by m into what is our 8.3 into temperature is 300. So pi is going to be 200 that we already found, and 200 that is equal to 2 by m into 8.3, so into 300. So what is the value of m then? You will get 24900, and this is going to be equal to anyway gram per mole, molar mass now. So finally you have 2.49 into 10 power 4 gram per mole, and we have to express this into 10 power 4 that we already got. So answer is going to be 2.49. An electrochemical cell is fueled by the combustion of butane at 1 bar and 298 Kelvin. So what is this electrochemical cell and why it need to be fueled? So I have an electrochemical cell where this cell is going to undergo redox reaction, but this redox reaction is an non-spontaneous redox reaction. So what does it mean non-spontaneous? This redox reaction, the reaction won't happen on its own. We have to supply energy to this system so that this reaction can happen. So this energy is derived from the combustion of butane. So if we found how much energy is going to give out by the butane non-combustion, so that I can find the cell potential for this cell. So combustion of butane, first write the equation. This equation is not balanced. We can balance this equation using this formula. If you use this formula, you will get this equation. Now, how do I find the energy released per mole of this compound, of this butane? That can be given by the delta G of this reaction. Okay, that I can calculate by delta G or not of formation of CO2, or I can first write the equation product minus delta G not of reactant. So what are the products I have here? I have CO2 and H2O. This side I have O2 and C4O10. Here I can note this. It O2 is an elemental form. So its delta J is going to be 0. So delta F of delta G naught of CO2, I have per mole it is going to be, so I have 4 CO2 molecule over here and I have 5 water molecule minus of butane. So these values are already given in the question. Minus 394 minus 237. So CO2 is minus 394 and this H2O is going to be minus 237 and I have minus of minus like 18. So these all of them are in kilojoule per mole. So if you do this calculation, you will get around 2743 kilojoule per mole. This is the amount of energy that I can derive from this equation, derived from the combustion of butane. So how do I find using this the electrode potential of this cell? That I can find using the relation between delta G and E naught. What is n here? This is the most important one. How do I find the n factor? That is how many electrons involved in this reaction. I can see here I have 1 mole of butane. I can use oxygen as a reference first. So for oxygen, one oxygen, it is going to be in 0 oxidation state and here it is going to be in minus 2 oxidation state. So I can say that for one oxygen, O22 like CO2 or H2O, it is going to be 0 to minus 2. So the n factor is 2 for one oxygen. What about how many oxygens are involved in this reaction? For 1 mole of C4O10, 13 by 2 O2. So I can break it. It is going to be 13 by 2 O plus 13 by 2 O. Since 2 O are there, I am going to write them how many atoms of oxygen is there. So I can get 13 O. Each n factor is 2. So 13 into 2, n factor is going to be 26. So the n is going to be 26. What is the delta G of reaction? 2743 and it is in kilojoule. We just have to express in joule per mole. So into 1000 is equal to minus 26 into F into E naught. Why I am keeping this F constant? Because in question they have given us x by f. It is not mentioned here, but it is x by f. Okay. Now I can cancel this minus sign. So if I find the inert cell of this reaction, it is going to be around 105.5 divided by f into 10 power cube. So the answer is going to be 105.0. So this x is going to be 105.5. The sum of the spin only magnetic moment values of we have given with two complexes. Both of them are manganese complexes. But the thing was, one is with weak field ligand and another one is with strong field ligand. So, what is the oxidation state of Mn over here? So here it is going to be equal to minus 3 and I have like 1 bromine minus 1 and I have minus 6 over here for 6 bromines and this is going to be x, so I'll have plus 3 and the same thing over here, so because Cn minus will also be having minus 1 charge and have 6 ligands, Cn ligands are there, so x is equal to plus 3. What is the ground state configuration of Mn? I know that organ 4s2 3d5, or you can write this as better way 3d5 4s2 because fourth cell is going to be the valence shell. Now what about the Mn3 plus? The same organ, but we have to remove 3 electrons. First 2 electrons are removed from s orbital because it is the outermost shell, and then 1 electron from 3d. So this Mn3 plus is going to be a D4 complex. So I'll have a splitting octahedral of two things. So this one is for weak field ligand. So weak field ligand, the separation won't be not too large. So the pairing energy will be lesser, like will be greater than the splitting energy. So the lowest energy is splitting energy. So the fourth electron will goes over here. And over here, the splitting will be very large since it is a strong field ligand. So the splitting energy is greater than the pairing energy. So the minimum energy is going to be pairing energy. So the fourth electron prefers the minimum energy spent. So it is going to get paired. So now I can check the unpaired electrons over here in manganese bromine complex. I'll have a 4 unpaired electrons, and in manganese nitrile group I'll have a nitrile ligand. I will have a 2 unpaired electrons. So how to find a spin only magnetic moment? Mu is equal to root of n into n plus 2. N is nothing but the number of unpaired electrons in a compound. So in MnBr 6, n is equal to 4. So mu is equal to root of 4 into 4 plus 2. So 6 4 are 24. So 24 is going to have the root 24 is going to have the value of around 4.9 or 4.89 exactly. Next I have a strong field ligand where 2 unpaired electrons are present. So here I have 2. So 2 into 2 plus 2, 4. 4 2 are 8. So root 8 is going to in between 2 and 3. So it is going to be around 2.84 bm. So the sum of 4.89 plus 2.84 is going to be around 773. So the answer is going to be 770 to 773 Bohr magnetron. A linear octosaccharide on complete hydrolysis produces 3 monosaccharide. So first of all, what is an octosaccharide? So octa means 8 that we already know. So it is nothing but the 8 units of monosaccharides which are linked together by glycosidic linkage. Let me draw it first. 1, 2, 3, 4, 5, 6, 7 and 8. So how many glycosidic linkage they have? So they have 1, 2, 3, 4, 5, 6, 7. When I'm doing a hydrolysis process, what is going to happen? All this monosaccharide is going to get hydrolyzed and all this glycosidic bond is going to break by the water. So how many I have? 7. So how many water do I need to break one molecule of this octosaccharide? I need 7 water molecules, right? So I can write it as octosaccharide needs 7 molecules of water to become 8 units of monosaccharide. So they have given these are producing 3 monosaccharides, ribose, 2-deoxyribose and glucose. So this 8 units will contain, I don't know, like we don't know how many glucose I have, how many ribose I have and how many deoxyribose I have. I can split it as X, let's say X unit of ribose is there and Y unit of deoxyribose is there and Z unit of glucose is there. Okay, now they have given one more data that amount of 2-deoxyribose formed is 58.26% weight by weight. Total amount of monosaccharide. How do I know the total amount of monosaccharide? For that, I can use the law of conservation of mass. So I have 1024 gram per mole of octosaccharide. I'm going to use 7 mole of water, which is going to weight 7 into 18 gram. So now, if these are reacting now, it should be equal to the amount of product formed, the weight of products, right? So I can tell like 1024 plus 7 water molecules weight will be equal to X into weight of ribose. Weight of ribose is going to be 150 now, plus Y units of deoxyribose and their whole weight. So 1 is going to weight around 134 and Y molecules will weight Y into 134 and I have Z into 180 because of glucose. This is Z, don't take it as 2. Okay, Z. Okay, now what is this number? This number is going to be 1150. It is equal to 150x plus 134y plus 180 Z. So what they have given is deoxyribose, this one. So Y into 134, this much deoxyribose weight will be equal to 58.26%. I can write them in fraction of 1150. 1150 is nothing but the whole unit of this whole value, right? Okay. Now I want to find, like, now I can find the molecules of, like, how many molecules of deoxyribose is there. Y is going to equal to around 4.99. I can take it as 5. Now this equation will become 1150, which will be equal to 150x plus 134 into 5 plus 180 into z, right? So this is going to be equal to 750. So I can bring everyone this side. So 150x plus 180 z, that is going to be equal to this. So I can take like 150x plus 180 z, that should be equal to 1150 minus 750. So if 50 gone na 1100 and 700 gone na 100, 600, like 400 I will have. So 150x plus 180 z. This x and z is going to be a unit, right? It can be 1, 2. It is going to be an integer, not decimal. Okay. So I can try with different units, like minimum possibility, that is going to be x is equal to 1 and z is equal to 1. What do I get is 150 plus 180 equal to 400. No, it is not equal to 400. So this value is going to be equal to like 200, 330, right? Now I can, like, x is equal to 2, z is equal to 1. So what do I get? 1050 into 2 plus 180, that is going to be equal to, not equal to 400, but still 300 plus 180, 480. No, it is not. And what if I take x is equal to 1, z is equal to 2? Then I will get 150 plus 360. So it is going to be 510, right? And this is not equal to 400. This is like too much. So this is not, like, upon comparing these values, like this I can't take. Sorry, this I can't take because it is a minimum. It should cross at least 400 so that I can completely know how many exact units are there. Like, so here I can take like 480 and 510, which is going to have more accuracy. That is going to be 480. So I can take this 480 as an answer. So x is equal to 2 and z is equal to 1. So which is nothing but this ribose is going to have 2 units. That is going to be our answer, because they are asking about the number of ribose units, and the number of glucose units will be around 1, but it is not going to be an exact value. So this is just an assumption, but answer should be 2.